Hello. Alright, so I'm gonna solve 5.6.5 and I'm gonna do part A first. And part A asks why you can't evaluate the integral from 0 to 1 of x tan x dx exactly using u substitution or integration by parts. So the reason you can't use u substitution is because there's really no productive way to let u equal anything that would yield a productive result. So for instance, if you let u equal tan x, and then du would have to equal secant squared x dx, and that doesn't really make the integral any simpler to solve. It actually might make it harder. So then if you tried letting u equal x, then you would get du equals dx, and then you basically just get the same thing. You just get u tan u du. That's definitely not any simpler. You also can't use integration by parts because, again, there's really no productive way to substitute. So if you let u equal tan x, then dv would equal x dx. And then you would have du equaling secant squared x dx. And you would have v equaling x squared over 2. Well, that definitely makes it no simpler because then you would have to solve the integral secant squared x times x squared over 2 dx. That's definitely not any simpler. And then you would have, if you tried it the other way, you would let u equal x, and you would have dv equal tan x dx. Then du equals dx. Okay, but then v would equal something really funky. It would equal the negative natural logarithm of cos x. I definitely don't know how to integrate that. So you can see that u substitution and integration by parts will not work any way you substitute it. So you must approximate, which we will do in part B.